So good afternoon, everyone. I'm Mohammed Abdul Haq. I'm from Tokyo Metropolitan University, and my partner is from NTT Communication, Sahita Hashima, and my professor, Nobio Tagawa. So right now, I want to present my research. It's about RacketDB. It's a comprehensive dataset for badminton racket detection. I will introduce what is the RacketDB. Nowadays, badminton is a very famous, well-known sport in the world. And in the last 5 years, badminton research is improving. But the research in badminton is focusing only the player detection, player pose, and shuttlecock detection. And no one talking about the racket. What is the racket? Let's go to another dataset. So there is an existing dataset. It's called Coco, if you know. It's from Microsoft, and Pascal VOC from 2007. There are some frames that contain racket, but it's only a tennis racket. Even there is badminton racket, they label it as tennis racket. This is the example of the Coco dataset. There are many frames, and this is from POC. Then from the challenge, I introduced a RacketDB. This is developed to address this gap to provide a comprehensive dataset only for badminton racket. This is the dataset details. So the datasets used in this work is from videos collected from a study of the two player versus two player. This is double match. And to annotation, I annotate using CVAD. CVAD is a tool from Facebook. So I semi-manual annotate the racket one by one. But you can see there are 4 rackets, but I only annotate 2 rackets. Because when I annotate the 2 rackets behind the net, the detection is very, very bad. There are many misdetection. So that's why I annotate only 2 players. I mean 2 rackets. And this is the distribution of the rally count. So in the videos, there are many rally of badminton match. So there are many videos, and this is the ID. And I compare to the Coco, but yeah, because there is no badminton racket dataset right now, so I just compare with racket on Coco datasets. So racket on the Coco, there are 3,000 level racket, and in RacketDB is around 16,000 annotation. And for the total, I train in a 16,000 frame. I mentioned this is a frame, not a label. And the testing is around 3,000, and validation is around 3,000 again. So I also evaluate my datasets with many deep learning models. The first is YOLO version 5 and version 8. Even we know right now there is YOLO version 12, but I use a version 8 and 5. And the MAP 50 is around 77 and 78. And faster RCNN is likely same. But in the MAP 50 and 95, it's higher for YOLO version 5. And this is the detection transformer. It got not too good in these datasets. It is because the transformer detecting globally, not locally. So that's why the transformer is not very good to detect the racket that has a small visualization in the frame. And I also try to compare with Coco datasets, and Coco datasets only got 63%, and MAP 50 and 39 and 50 90. So for fairness, I So this is a qualitative result. This is a Coco, and this is a RacketDB. So let's discuss about the Coco. In the Coco, I detect using tennis racket because in the Coco there is no racket. So there are many misdetection. In here is a good detection, and in here the racket is not wrong detected, and in here it's not detected. This and this is not all detected. And when we use a RacketDB, it's very well detected. Even it's small racket in here, and it can detect because the racket is in front of the player, so even human cannot see, so the computer also cannot see. Also for the fairness, I also try to train in another frame that I didn't train. So this is a frame from the TrackNet datasets. This dataset is for the shuttlecock detection, but I use for the racket detection. And the racket is well detected, but yeah, unfortunately, the racket behind the net is cannot well detected. And in this frame, it's a 4K quality, and in this frame, it's around 480 pixels. So it's very good for the detection. And for the result and discussion, there is some failure detection. It is because the occlusion, when the racket cannot see, the camera cannot see. And the next is lighting variability. When there is a light changes, sometimes it's not detected. And this is the very hard challenge in the badminton. So motion blur, when the player doing a smash or fast movement, it cannot detect. So the racket is literally disappear. So that's why it's not detected. And yeah, so this paper introduced the RacketDB, specialized datasets for badminton racket detection, and this RacketDB just evaluated using YOLO version 5, version 8, and transformer and faster RCNN. And in my future research, I want to detect all rackets behind the net, but from the top view. So, and then I want to make a rotated coding process. So that's my presentation, and this is my research. Thank you.
Presentation questions. So I have a question. How many annotators involved in this work?
Annotators?
Yeah, like how many people annotated all this?
So it's only me.
And so each image can have like several, like when you annotate, when you label, each image can have several labels, right? Like several volume processes.
Yeah, there are two.
And have you tried your solution for the videos? Like, only on the videos.
So this is from videos.
I mean, test on videos.
Yeah, it's
like real time.
Real time, no. It's offline.
And is there any difference between like badminton racket and tennis racket detection?
So if we see this is the level we cannot see. It tells the tennis racket.
Yeah.
So Coco also detects the racket as a tennis racket, but maybe when I try to detect a tennis racket with RacketDB, it sometimes detect and sometimes detect. It's like detecting dog and cat. Maybe.
Okay, thank you so much for the presentation.
I think question.
Yeah.
What's the main reason for detecting the racket? Because if you walk quite fast, you can't even see it in the image, and you can't even track it in any way. So what's the use of it?
Thank you. So for final research of my research is for the sport analysis. So when in 2023, I found a paper that focused on mixed reality of the player, and they can visualize the shuttlecock and the player. And in the before conclusion, there is a evaluation from the coach, and they want to the racket movement. So that's why. So from the coach perspective, they also need a racket movement, and this is from a 4K quality video.
Yeah.
I think when the video has a high FPS and high quality, I think it can be detected. Even now, the camera is improving.
And probably you can also introduce some kind of tracking response in case if there is a blur.
Yeah.
You mentioned that you will be doing research in the future with the top view. So do you have data for that?
Yeah. So right now I'm working on that, and our a collaboration with another university and tech student practicing with the camera on the top.
So it's a private data. Is it
Yeah.
publicly available or not?
And this is the public. This
The one you are doing in future work on the top view.
I hope it can be published. It's Oh.
It's in the book.
thank you for the question.
I heard that the racket can have sensor on inside of the racket. You have if you work on combining the sensor information and the video image analysis.
Thank you for the question. So around 2020, there is a IoT device from China. They put the sensor. For example, this is the racket. They input here, but it will affect the game. So in the badminton, there is a player that want to use a not weight like racket, but when the sensor is applied, it's a different. It will be not good at smash or a defense. So I think it will be change the game. So that's why I only take from the camera only.
My question was maybe can it help for the dataset, but after the player will not have access to the sensor, so it's just for entering the network, for example. At first having kind of information, but after not really need but also that.
I think that's a suggestion, right? So yeah, it can be used for the training and help to the training.
But you're already using a video per frame to then label the rackets. I think nowadays there are like good algorithms for tracking. So if you already have the data, and then you could try some off-the-shelf model for tracking in videos, and then they will be able to track the racket without having to rely on an external sensor.
Nowadays the neural network is very we cannot imagine like this. So I think the newest neural network can be detect rackets very smooth.
Is there any other questions? Thank you so much for the presentation.